Hello and welcome to Scatter Plots and Lines of Best Fit. Now you may have already seen this in your chemistry class or your physics class where you're plotting data and finding the lines of best fit. So this might be a review for some of you. Okay, if you get your notes and your pencil and a calculator to be handy next to you, we'll get started. So what is a scatter plot? Let's write this down in your notes. It's data that's real data that does not always make a perfectly straight line. In real life, data is scattered all over the place. It's not a nice and perfect line. So you may see a scatter plot that looks like this. This scatter plot would have no relationship between X or Y. It's completely scattered. So we would say that has no correlation. You might see a scatter plot that looks like this, a positive correlation. It looks like all the dots are in a straight line, but if we were to draw that line, it would have a positive slope. So we call this a positive correlation. Now we might see a graph that looks like this, and all those data points are kind of looking like they're going down in a negative slope sort of way. So we would call this a negative correlation because it looks like a negative slope. So what I want to do is I want to take you to this website that I have. And as you can see, this is a weak correlation, not a weak positive. Not very many of those points are close to that line. But if I show you how I can make a weak positive into a strong positive, that's a really strong positive. The slope is sloping upwards, all the points are upward. They're all in a nice, perfect line sloping upwards. Here they're getting just a little bit further away from the line, and as you could see before, we had very weak correlation. We can't really draw a line between any one of them. And then if we have a negative strong correlation, you can see how those points are trending downwards, but at the same time the points are getting closer and closer to the line until it almost makes a perfect line. So this idea is what we're going to focus on today. We are going to focus on scatter plots and drawing lines of best fit, just like you do in your science class. So you might see this. This is a real life scatter plot where it's comparing age and reaction time and how age impacts the reaction time of, oh, sorry about that. Age impacts the reaction time of a person. So in this case, you can see that scientists have made a survey and they've plotted all their data points on this graph, and they now may want to predict what an 80-year-old might have, what kind of reaction time an 80-year-old might have. But they didn't survey the 80-year-olds. So what they would do is they'd plot all these points on a scatter plot, and then they would draw their line of best fit. And then once they have their line of best fit, they can predict those things they're not already on the graph. So they could predict what an 80-year-old might be. So lines of best fit, let's make sure we write this down in our notes. A line of best fit is a line that comes close to the data points. It may pass through some of the points, none of the points, or every single point. That would be a strong correlation. It's useful to help us show a relationship between two things, an X and Y values, and to predict missing Y values, like I talked about before in the age and reaction time. All right, so let's do one example. We're only going to do one example. So I want you to take this data and I want you to write it down in your notes because we're going to find the line of best fit. Okay, given these data points, now I am going to have you graph it. So if we're graphing a real world line of best fit, first we'd have to have a title. This one doesn't have a title because I don't know what the X and Y's are, but tomorrow when we do this in class, you will need to have a title. we only are going to talk about quadrant number 1. All our x and y values are positive in this case, so we're going to stick with the first quadrant. This is our x-axis, this is our y-axis. We would want to label, just like in the previous example, if we were talking about reaction time, we'd want to put that there, and then age down here. But we want to make sure that we label our x and y axes when we can. So then, how do I want to number this graph? How do I want to make sure that I can get all these points? Well, it looks to me like we could go by 0.5. So we're going to go by 0.5. 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. And I'm going to do that same thing on the y's. So 0.5. I'm actually going to move my y-axis up a little bit here. So it's right there. Two 2.5, 3, 3.5, 4. Okay, now I've got my graph labeled correctly. Got my x-axis, my y-axis, I got my intervals. Remember, they have to be the same amount when we're labeling our intervals. And now we're going to plot those. So 0.5, 2.9, you can do that. That's about right there. 1 and 2.75, that's about right there. Oh, nope, it's a little bit further than that. My apologies. 1.5, 2.6, here's 2, it's about right there. It's closer to 2.5, 2, 2.3, 2.5, 1.4, 3, 1.3, 3.5, 1.1, and 4 and 0.75, which is about right there. So you can see that this relationship in this scattered plot is kind of trending downwards, like a negative slope. So if we were to go ahead and draw a line of best fit, remember a line of best fit is a line that comes really close to all the data. It might go through some of the points, but not all of the points. Okay, I'm just going to draw a random line here. My line is a little off. It's okay if your line is a little off. I'm going to try to make it go through those 2 points right there. Okay, and there was another point right there. That's where my line of best fit falls. Now, yours might not be exactly in that spot, but you are going to draw the best line of best fit you can do. Remember, this is an approximation. It's not an exact value. So we're going to go ahead and see that if I were to do it more nicely done on a graph, you can see that's where we're going to have it. Now what we can do is we can find the 2 points that we went through from our graph. And I went through this point right here, which is labeled 1, 2.7. And now this point right here, which is 3, 1.3. Now, if you didn't use those 2 points, if your line doesn't go through those 2 points, it's okay. It's an estimation. It's not perfect. But once I find 2 points that my line of best fit goes through, we can go ahead and find the equation of the line, just like we have been doing. An equation of the line, you need what? Y equals mx plus b. And the 2 key features of y equals mx plus b is finding my m and my b. So once I find those 2 points, I can find my slope. So my slope is equal to y2 minus y1 over x2 minus x1. Y2 is 1.3 minus 2.7 all over 3 minus 1. And that will give us 1.3 minus 2.7 is negative 1.4. divided by 2, and my slope is negative 0.7. So that's my slope. Now that I have my slope, I need a y-intercept. How do I do that? I use one of those random points. I'm going to use 3 and 1.3. So I'm going to go ahead and use 1.3 as my y. My m is negative 0.7. My x value is 3. And I am going to solve for that b. That b that we're looking for, that y-intercept. Okay, negative 0.7 times 3 is negative 2.1 plus b equals 1.3. Add 2.1 to both sides, and I get 3.4 equals b. Now, what is the equation of this best fit line? The equation of this best fit line is y equals negative 0.7x plus 3.4. Now, you may have got a different line of best fit, but it should be pretty close to that. It is possible that if you use 2 different points, because we drew our lines differently, that you may have a slightly different equation. And that's when we're doing lines of best fit, it is an estimation. So now what we could do is we could make a prediction. What would 4.5 be on our table of values? What we could do is we could plug 4.5 in for x and find out what y would be. And if we did that, plugged 4.5 in there, you would find out that y is equal to 0.25. So that is a prediction. We made a prediction based on our estimated line of best fit. So that's how we do it algebraically and by hand. But how do we find the actual best line of best fit? Well, tomorrow we're going to use technology to help us find the line of best fit that is accurate, that isn't exact. So be prepared to come to class tomorrow using a graphing calculator and not calculating it by hand, finding the actual value with the calculator. So that is all I have for today. Have a great night. We'll see you tomorrow.